Welcome to our second section in Chapter 10. Today we're going to be looking at the areas of trapezoids, rhombuses, and kites. Before we get started with that though, I want to review the formulas that we learned in the previous section where we had the area for parallelograms and for triangles. Now we also talked about the area of a rectangle, but remember a rectangle is a parallelogram, so it uses the same formula, which is base times height. The area of a triangle we learned comes from a parallelogram, and it's just half of that, so it's 1/2 base times height. Going to be very important that we remember these formulas as we move forward, particularly as we add formulas to it. The first formula we're going to add to our list is the area of a trapezoid, and the area of a trapezoid is 1/2 times the height times the sum of the two bases. So if we look here, we've got the height, we've got the top base and the bottom base, and where this formula comes from is if I draw in the mid segment of my trapezoid, which means that these two segments are congruent, these two segments are congruent, and if I take this part up here and I flip it around, turn it over basically, so that it extends out this way, this side is going to end up coming over here, right? This base is going to end up being on the bottom, and the height I basically split in two. So this distance is half the height. So you'll notice I now have a parallelogram, and the area of a parallelogram is base times height. Well, the base of this parallelogram is the two bases added together, base 1 plus base 2, times what was half of the original height, and that's where this formula comes from. So now if we use this to approximate the area of Nevada, which is down here, we're going to start with our formula, 1/2 times the height times the sum of the two bases. So my height is actually the distance between the bases. It's not necessarily going to be going up and down. In this case, it's going side to side, and it's 309 miles times the sum of the two bases. So my short base of 205 plus my long base of 511. I want to simplify this part first. So I have 1/2 times 309 times 716. Then I can put all of this in the calculator, and when I do that I get 110,622. Now we're still dealing with square units because we're in area. My unit is miles, so my answer is in square miles. So Nevada, pretty big state, 110,622 square miles, give or take a few here and there. Another example, in this one we have a height of 7 centimeters and bases of 12 centimeters and 15 centimeters. So again, we apply the same area formula, 1/2 times the height times base 1 plus base 2. So my height is 7 centimeters. My bases are 12 and 15. If we simplify that sum first, we get 1/2 times 7 times 27, which I then put in my handy-dandy calculator, 94.5. My units were in centimeters, so my area is centimeters squared. Okay. Another example, this one is a little bit more complicated, but don't let that frighten you. In this case, I know the top base, my short base is 5 meters, my long base is 7 meters. So if I have my formula of 1/2 times the height times the sum of my two bases, and I plug in the information that I have, I do not have the height. So even though I know my bases and I can find the sum of the two bases, I still need to find my height, and that's missing. Well, that would be this distance, or if I draw it in over here, it's also going to be this distance, but unfortunately I don't have it. This problem doesn't give it to me. However, it does tell me that I have a 60-degree angle right here, which when I drew in this altitude, this height, which gives me a right angle down here, if I look just at the triangle, that means this angle is 30 degrees. And if we remember from our previous chapter, in chapter 8, when we have a 30, 60, 90 right triangle, we have a special relationship that exists where the side opposite the 30-degree angle, if we consider that S, the side opposite the 60 is that length times the square root of 3, and opposite the hypotenuse is that length times 2. So if we know this length, we can find the other two. Well, looking at my triangle, this one opposite the 60 is what I'm looking for. So side times the square root of 3. So I need to find my side length, or I need to find this length right here. Well, the nice thing about this, since I drew in this altitude, basically I have a rectangle here, which means this length is 5 meters because the opposite sides of a rectangle are congruent. If the whole thing is 7 and this is 5, that means this has to be 2. And so this length right here is going to be this times the square root of 3, or 2 times the square root of 3. And that's in meters. Now I have all the information that I need. If I plug in my height over here, 2 radical 3, and we multiply, so 1/2 times 2 radical 3 times 12. Now if I multiply this out, I'm not going to use a calculator because the calculator can't handle the square root of 3 and give me exact. It'll approximate it. 1/2 times 2 square root of 3 is 1 square root of 3, or just square root of 3. Multiply that times 12, and we get 12 square root of 3. My answer is going to be in meters squared. And there we go. Now if I wanted to find the approximate distance, if I'm looking for something in actuality, then what I do is put this in a calculator and it will give me a decimal approximation of that. But for right now I just want the exact, so I'm going to leave it there. So that's trapezoids. Let's move on to rhombuses and kites. They actually share a formula. It is 1/2 times diagonal 1 times diagonal 2. And what that does is it actually gives the diagonal 1 times diagonal 2. If we did that, it's basically the base times height of a parallelogram, because if what I would do with that is get this shape here. Well, these two triangles are congruent, those two are congruent, those two are congruent, those two are congruent. So what I have is basically double my shape, which is why I take half of it. Okay. One thing that we will remember in a rhombus, the diagonals bisect each other. In a kite, they do not. However, this diagonal is bisected, so those two parts are congruent, although these two parts are not. So that's something to keep in mind. So if we look down here, I want the area of this kite. It's 1/2 times the first diagonal times the second diagonal. So we have 1/2. Now if I look at the first diagonal, I'm going to call that LN. This part is 3, this part is 3, so the whole thing is 6. The second diagonal is KM, so we have this part of 2, this part of 5, so the whole thing is 7. So we have 1/2 times 6 times 7. 1/2 times 6 is 3. 3 times 7 is 21. My unit is in meters, so I have 21 meters squared. Okay. One more example. Now we're going to look at a rhombus. The high occupancy vehicle lane, or the HOV lane, is marked by a series of diamonds, and these are actually rhombuses that are painted on the pavement. You can see one right over here. We want to find the area of the diamond. Now it's a rhombus, so we're going to use the formula of area equals 1/2 times the diagonal 1 times diagonal 2. And so we need to know what the length of diagonal 1 and diagonal 2 is. Now if I look at this figure where it gives me some information, one diagonal, I have part of it, this half is 2.5. So we'll call that diagonal 1, and since half of it is 2.5, the whole thing is 5 feet. But I need to find diagonal 2. I don't know what that is. What I do know is that this distance right here, the side of the rhombus, is 6.5 feet. Well, if I look just here, this is a right triangle, and I have a leg and a hypotenuse, so I can use that to find the other leg, because if we recall our Pythagorean theorem, a squared plus b squared equals c squared in a right triangle. So if I think of a squared as being the length that I'm looking for, b squared is going to be 2.5 squared, and that equals 6.5 squared. And now we just have to simplify and solve. 2.5 squared is 6.25. 6.5 squared is 42.25. If I subtract 6 1/4 from each side, I get a squared equals 36. Take the square root, a is 6. So my second diagonal, if this distance is 6, is the whole thing, my second diagonal is 12. And so now I have all of the information that I need to plug in my formula. So we have 1/2 times 5 times 12. 1/2 times 5 times 12 gives us 30. We're dealing with a unit of feet, so my answer is in feet squared. That's how we find the areas of trapezoids, rhombuses, and kites. Thank you very much for joining in. I will see you in class.